candidate, they all fail. They all end up being pumpable. Well, then you might have to do a double think and say, well, maybe the language actually is regular. But it's hard to say. You don't know until you actually find one counterexample. But if you never find one, well, the question remains open. But then you become increasingly suspicious that your language actually is regular. Okay. Now there's another way to prove this C is non-regular, and that's using the previous example. Remember language B? What was language B? It's the property for that. The strings in that language was the set of W, the strings, and W is of the form 0 to the n, 1 to the n. Okay, so you've got an equal number of zeros and ones in your string, but all the zeros are on the left side and all the ones are on the right side. Okay, so that's what B is. Now, this is sort of a different approach. You can actually show that C is non-regular by using the knowledge that we have now from a previous example that B is non-regular. It's a rather ingenious little proof. Okay, so here's how it works. Okay, so you're assuming, again by contradiction, so you assume that C is regular. Okay. Now this expression here, this regular expression, 0 star 1 star, that is regular. Why is that? Well, 0 is a regular expression, therefore 0 star is a regular expression. We spent a lot of time proving all that kind of thing. Now 1 is a regular expression, so 1 star is a regular expression. Okay? So 0 star is a regular expression and 1 star is a regular expression, and then we concatenate this shorthand. The little circle here is missing, but it's implied. So if you concatenate a regular expression with a regular expression, you get another regular expression, which is shorthand for a language. Okay, so if you're assuming C is regular, and we know this is regular, so therefore that's a set. So the disjunction. Sorry, what do you call this? What do you call it? I'm forgetting. Intersection, right? Yeah. So let's see. There was a footnote, I think, on page 46 of your text. Have a look. So regular languages are closed under intersection. We didn't actually do that, did we? We showed. We didn't do that. We did not do that in detail. We showed that union, concatenation, and star. They were the three regular operators we concentrated on. So I guess intersection is another one, right? Anyway, so if that's regular and this is regular language, that's a regular language, then the intersection is also regular. Okay. But this C intersection this set is actually B, if you think about it. Okay? Now what is C? It's all those strings. It's the language of all those strings where the number of zeros and number of ones is equal. But if you then intersect that with this, now what's this? Well, this is all possible strings where all the zeros are on the left and all the ones are on the right. Now if you intersect those two, what you will get is, this is homework, well I'm solving it for you right now actually. If you work out what this actually is, now remember C is just all those strings where the number of zeros and number of ones is equal. But then you intersect it with these, and this is the set of all strings where all the zeros are on the left and all the ones are on the right. Now you intersect those two, you will get all those strings that are of the form equal number of zeros and ones, and all the zeros are on the left and all the ones are on the right. Well, that's B, right? That's the language B from the previous board. B is 0 to the n, 1 to the n. Okay, so this is just B. This here is B. All right. Now, intersection of now we're assuming C is regular. Okay, regular language. We're assuming we know this is a regular language, so the intersection should be a regular language. But this intersection is actually B, but we know B is not regular. Okay, therefore, now we know that's regular. Therefore, if we intersect two regular languages, the answer is regular. This operator is regular. So the only way we can make the whole thing not regular, because B is not regular, is that C is not regular. Okay, so there's an alternative proof that C is not regular. All right, now here's the third example. What's going on here? So you got a duplicate, like you got a substring, and its duplicate, like a clone, right? Okay, whatever this is, it gets cloned, right? And W is just a string, an arbitrary string, a binary string. Right? That's all that says, right? And you have to now we'll call this language of the set of WW, what a binary string followed by its clone. Okay, and we have to show that F, which is that language, we have to show it's non-regular. Okay, again using the pumping lemma, again by contradiction, right? So you assume F is regular, the opposite of what you're trying to prove. Let P be the pumping length as usual. Okay, so all that's the same. Now now the choice of the candidate string you're trying to show cannot be pumped. Yeah, that's critical in all these proofs. So here's a critical assumption. Let S use your trial solution, trial string that you're trying to prove cannot be pumped. Let it be 0p1, sorry, 0 to the p, 1, 0 to the p, 1. Now, can you see 0 to the p1? And you've got it twice here, so here's your clone, the copy of this. Therefore, S is of this form, WW. So this string here belongs to this language F, because it satisfies this property, right? Here's your W, and here's your clone. So it's of the form WW. So this string belongs to this language, and obviously the length of this thing, well, what would it be? Well, it's 2p plus 2. That's pretty obvious, right? Well, and hence the length of this string is greater than p. That's obvious because 2p plus 2 is bigger than p. Okay, so that makes sense. Yeah, they're saying here, because S, this string here, it belongs to F, and its size is greater than p, so it satisfies the conditions for the pumping lemma. Okay, and the pumping lemma then guarantees that this S, in other words, this, can be split, as usual, into the three substrings x, y, and z. Okay, and that this string satisfies the usual three conditions of the pumping lemma. Okay, so now we'll try to show that this is impossible, and again the condition 3 will be critical. We will use it to show that this S here cannot be pumped. All right. Because if we did not use that third condition, then we could probably show that S is pumpable. Okay. Now, let's see. Hold on. So if we did not have this third condition, then we could pump S. Why? Asked to do this for homework. Let X and Z be the empty string. So again, with condition 3, it was the same query. therefore y has to consist only of zeros, so it's the same remark as in the previous example. And therefore, now x, y, z has the form WW, okay? And you pump it a little, you put an extra y in there, and they're all zeros, so that destroys the WW form, okay? So therefore, the pumped version is not of this form. So the pumped version does not belong to the language. And hence you found your counterexample. You found a string, S, that cannot be pumped. Okay? So that's the third example. So again, the question mark, this remark, so using condition 3, in other words, the length xy is less or equal to p, the pumping length. Okay? Therefore, your y has to consist only of zeros. Why? Homework for you. Something to think about. If you like. Now maybe it is trivial. Maybe I'm just missing it. Maybe it's not. I don't know. Fun for you something to think about. All right. So that's the proof of the third example, and we have two more, but that will be for another board, and it's already 3 AM.